Okay, so we're going to do maximum depth of binary tree. Make sure you do this after doing, what's the other one called? The other one is called binary tree level order traversal. And make sure you do it before you do minimum depth of binary tree. Because minimum depth of binary tree is best to do it using breadth first search with a queue. And for this one, because it's maximum depth, one of the intuitive ways of doing it is using depth first search recursively. And you can do it using top-down DFS, whereby you maintain the height of the tree as you go down, and you have a maximum height counter, a maximum height variable, and then you compare the height as you go down, the height at each level as you go down to the maximum height variable. That's the top-down DFS. Then bottom-up DFS, you return values, you return maximum height values at each level, right? So from the leaf node, you return 1, but then at each level you have a height from the left and the right, and then you compare which one of the two is the max height. And then one of those is the ones that you return at each level. So with the bottom-up DFS solution, it's going to have a return value. So you're actually going to return DFS, that DFS function. But I think the best solution for this is BFS. It's iterative. You don't spend stack space with the recursion. So this is what we're going to use here, but if you want, you can go ahead and do the top-down and bottom-up DFS. And since I've already done the drawings for these level order traversal type questions with breadth first search in minimum level order, I'm going to just write the code for this, right? Okay, so if root is none, okay, so anyways, let me first mention this. To find the maximum depth of a binary tree with level order traversal with BFS, you simply keep count of the number of levels. It's as simple as that, right? So if root is none, we return 0, right? Then we initialize our queue, right? We initialize our queue, which will be q is equal to collections.dq, and then root, right? Then we maintain num of levels, right? Which will be levels is equal to 0. And then we do the BFS. We do the breadth first search, which will be while length of the queue does not equal to 0, we get the length of this level, which will be the length of the queue. And we'll call it level n is equal to length of the queue. And since we're at a level, initially it will be our first level, we increment the number of levels. So it will be levels plus equals 1, right? So now we pop off, we iterate level len times and pop off to append child nodes for the next level, right? So simply for dash in range level n, we pop off and add child nodes to the queue. So node is equal to q.pop left. We pop it off. Then we add its children to the queue. So if node.left is not none, q.append node.left. Again, if node.right is not none, q.append node.right. So once we come out of this for loop, we'll have popped off all the nodes at this level and appended all the nodes for the next level, right? So all we left to do, because we're going to, that means at each level we're going to be, we'll add this for this level, we'll add it to the queue, then pop it off, add its children. So now obviously we'll have incremented the level, then we'll come to this level, pop this off, add its children, which is none, pop this off, add its children, which is these two, and obviously we'll have incremented the level to 2, and then come down here, and then pop this off, check that it has no children, pop this off, check that it has no children, but obviously we'll have incremented the level to 3. So all we're doing here is we are returning the levels, right? So we run this, voila. And that is our solution for maximum depth of binary tree. So this is ON time and ON time complexity and ON space complexity. And you can't do better than this. Even if you use top-down BFS, you're going to have a recursive stack in the worst case, which will be O of n. So that will be O of n space complexity. And since you're trying to find the maximum depth, you'll have to go through all the nodes. So it will be O of n time complexity as well. So that's the solution. Thank you. But make sure you do this. Make sure you do this before doing minimum depth of binary tree and after doing binary tree level order traversal. Okay.